absolute refractive index, and n equals 1 divided by at the bottom of the glass slab. I say it is placed at the point O 35 minutes. So now, since I knew the refractive index, light waves to wavelength given medium alley 4000 angstroms, I can simply substitute and get refractive index. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram Pre-University, Mysuru. In my yesterday's class, we started solving problems from geometrical optics, and the concept was refraction through plane surfaces. I expect you have gone through this session, you have revised the problems, you have a kickstart today. So, continuing my session today, we will work out few more problems from the concept geometrical optics. The next one, a very beautiful problem indeed. The problem says, light from a luminous point. Luminous andre? Yes, an object which is emitting light, an object which is giving out light. So light from a luminous point at the bottom of a glass slab. So the object is placed at the bottom of a glass slab of thickness 3 centimeter. The thickness of the glass slab is 3 centimeters, strikes the upper surface. The rays which are totally reflected, keyword to solve the problem, the rays which are totally reflected at the top surface outline a circle of radius 2.4 centimeter. I have to find the refractive index of the glass. So a beautiful problem. The problem says there is a glass slab. A glass slab. And we have a luminous point source which is placed at the bottom of the glass slab. I say it is placed at the point O. So this is the glass slab, a point object which is placed at the bottom of the glass slab. where I say it is placed at this point O, and I call this the upper surface. Now, very beautifully he says, the rays which come out of the source, the light which comes out of this object, it is striking the upper surface. So here, the rays strike the upper surface and they are totally reflected. Notice, beautiful agide. The light which is coming out of the source is striking the upper surface and it is reflected so that it forms a circle at the upper surface. I call this OA. This is AB. AB is the radius, and I have been asked to find very clearly the refractive index of the glass. Now from the diagram, students, so OA is 3 centimeters, AB is 2.4 centimeter, from which I have to calculate the refractive index. Now, the very clear assertion of the problem says the rays are totally reflected, which means I have some idea about the critical angle. Now, do I know any relation which will relate refractive index with critical angle? Yes, very much we have seen yesterday. N is 1 by sin C. Now from this triangle, so from triangle OAB, I will first calculate tan C, which is AB divided by OA, so that once I get the value of C, I can simply substitute and get refractive index. So tan C is AB divided by OA, or this is tan C equals 2.4 by 3, C equals tan inverse 0.8. Now all of you will use your calculators, refer to the logbook and get me the value of C. So this turns out to be 38 degrees 40 minutes. So very simple from the diagram. Whatever data is given, I have calculated C. So tan C is AB by OA, 2.4 by 3. So C is tan inverse 0.8. So we get C is 38 degrees 40 minutes. So substituting here, so this becomes 1 by sine 38 degrees 40 minutes. So on simplification, n turns out to be 1.6. So knowing a few concepts for a 5-marker, this is a cakewalk. The next one, students. A point source located 2 meters below the surface of a lake. Exactly similar to whatever we did in the first problem. There is a point source which is located 2 meters below the surface of a lake. Calculate the area of the surface. Area of the surface that transmits all the light emerging from the surface. Now, I have been asked to calculate the area of the surface given the refractive index of water is 4 divided by 3. Now, very much the same. So, this is the lake. We have the point object here, upper surface. Again, the rays of light, they undergo, they strike the upper surface, they are totally reflected back. This is C, the critical angle. This is AB, the radius. Keep in mind, now he is asking us to find the area of this circular patch. Area of this circular patch, which is emerging light through it. Circular patch. So, if I find out the radius, very simple, I can get the area. Area of a circle, pi r square. Now, refractive index is given. Again, n is 1 by sine c, or sine c is 1 by n. So, sine c is, n is, according to the problem, if you observe, 4 divided by 3. Refractive index is 4 divided by 3. So, this is 3 divided by 4. Now, C is sine inverse 0.75, from which I get C as 48 degrees 35 minutes. So now, since I knew the refractive index of water, which was given to be 4 by 3, I use the relation n is 1 by sine c, substituted, calculated C as 48 degrees 35 minutes. Now again I refer back from the diagram. Again I calculate tan C, which is AB divided by OA. Now look at the beauty. Very simple. What is AB? Nothing but the radius. So my objective was to calculate the radius. So AB is OA into tan C. So R was 2 into tan 48 degrees 35 minutes. So the radius turns out to be equal to 2.26 meters. So very simple now. So the radius of the circular patch is calculated. The final step, area. So area is pi r square. Do this bit of simplification, we get the area of the circular patch. The next one. This is a question from competitive exam, a CET paper, which says wavelength of given light waves in air and a medium are 6,000 angstroms and 4,000 angstroms respectively. Very clearly it says wavelength of light waves lambda air is 6,000 angstrom and in a medium it is 4,000 angstrom. That's all. With this, I have to calculate critical angle. Em kottidare? Light waves to wavelength air medium alle 6,000 angstroms. Light waves to wavelength given medium alle 4,000 angstroms. With this data, I am calculating critical angle. Now again, wavelength, critical angle. Now, when light travels in air, we define the refractive index as absolute refractive index. So we have N is C divided by V. What is C? Speed of light in vacuum. V, velocity of light in a medium. And now, also N is 1 by sine C. So, I have used these two expressions as the basic expressions to solve. Definition of absolute refractive index and N equals 1 divided by sine C. So, equating them, C by V is 1 by sine C. Now, somewhere can I introduce wavelength? Yes. Speed. So, here it is nu lambda 1 divided by nu lambda 2 is 1 by sine C. Frequency of a wave does not change as it travels from one medium to another. So, from that expression, sin C becomes lambda 2 by lambda 1. Sin C becomes 6,000 angstroms by 4,000, from which C turns out to be 41 degrees. So this is the other way, 1 by sin C. So this is 1 by sin C. So C becomes 6,000. This is sin inverse. So this is nearly 41 degrees. Again, a concept which you need to understand as a CET parameter. Next one. Find the refractive index. Now problems on Prism. Refractive index of the material of a prism of angle 59 degrees 42 minutes. Angle of the prism kottidare, which is 59 degrees 42 minutes. If the angle of minimum deviation, capital D, is 39 degrees 28 minutes. Now, refractive index of the prism is asked. Do I know any expression for refractive index in terms of A and D? Very good. So N is equal to sin A plus D by 2 divided by sin A divided by 2. A very simple simplification. Now substituting, N equals sin. Now A is 59 degrees 42 minutes. So 59 degrees 42 minutes plus D is 39 degrees 28 minutes. 39 degrees 28 minutes divided by 2 divided by sin 59 degrees 42 minutes by 2. Again, simplify this. So this turns out to be N equals 1.53. Nodi? Simple. The next one. This is asked for 5 marks. Find the angle of minimum deviation produced by an equilateral prism. The moment you say equilateral prism, A is 60 degrees, whose refractive index is 1.55. Now, angle of minimum deviation has to be calculated. So again, the same formula, sin A plus D by 2 divided by sin by 2. N is given to be 1.55. Sin 60 plus D by 2 divided by sin 60 by 2. Do the simplification. The simplification is an assignment for you all. So you saw just few relations, precise ability to simplify. You can solve problems from this chapter. Tomorrow we'll continue with few more problems from refraction. Until then, have a nice time. Thank you.